Oh, sorry. It should say recap of chapter 3. Recap of chapter 3.
Polynomials are the whole thing, like chapter part 1 and part 2.
I'll let you know before you go today. It's kind of connected though, so that's why it's hard to say. Okay, so what is x plus x? 2x. All right, and what is x times x? X squared. All right, so those are the two that people always mix up. X plus x is 2x. X times x is x squared. All right, and then 3x squared plus 5x squared is 8x squared. So don't make up those two. Okay, so we did a few rules, exponent rules. So when you multiply two numbers with the same base, what do you do to the exponents? Add. Right, so you multiply the coefficients, but then you add the exponents. Right, so copy it down because it does help you guys remember. When you multiply two numbers with the same base, we add the exponents. Okay. And notice right here, the 3 and the 2, the coefficient, you still multiply it, but it's the exponent that we're talking about, where you add. Okay. What if you are dividing two numbers with the same base? Subtract. You subtract the exponents. So again, in this case, your coefficient is just 6 divided by 2. Same old math that we've been doing for the last 14 years. 6 divided by 2 is 3, but we subtract the exponents to get x squared. Okay. What if you raise a power to another power? You multiply the exponents. So in this case, the 4 and the 3, when you times it, you get the 12. But don't forget, if your coefficient is inside the bracket, then you have to apply the exponent to the coefficient as well. So then in this case, 2 is also raised to the 3. So 2 times 2 times 2 gives you the 8. Okay. So these exponent rules apply to exponents. That's why it's called exponent rules. Coefficient, you still have to deal with it like normal. Okay, so those are the 3 exponent rules that we've learned in the first half of chapter 3. That's why I was like, when you asked me, is chapter 3 first part in it? It's kind of, because it's related. So now, the second half was when we add and subtracted polynomials. So, in other words, group like terms. Okay. The word like terms, you'll use it a lot. You'll use it in grade 9, you'll use it in grade 10. Make sure you know what are like terms. So for example, right here, if I have 2x squared plus 3x squared plus 5x minus 4x minus 6 plus 1, how many different types do I have here? How many types of terms do I have here? 3, right? So the x squares, these are considered like terms. I can group them together. So what is 2x squared plus 3x squared? 5x squared, good. And then 5x minus 4x, those go together. Those are like terms. And that gives you just positive x or plus 1x, doesn't matter. And then what are these called again? constant. See, that's why I keep testing you guys. -6 plus 1, the constants can go together, and it gives you -5. Am I going too fast? We're okay? Okay. I'm going too fast? Okay, I'll slow down a little. Okay. Okay, other than adding and subtracting, we did multiplying. Okay, so that multiplying, there's a proper name for it. It's called distributive property. So distributive property means multiply into each term in the bracket. Okay, so if I give this example right here, -3x squared times in bracket 2x5 minus 2y. Alright, that means I have to distribute that -3x squared into the bracket. So this times this, and this times this. Okay. When I multiply two numbers with the same base, what do I do with the exponent? Sorry? Add, right? Just like what we said in the first one. Yeah. So in other words, there's something like this. Okay, so Cindy is okay. I can give you a copy of this after. Okay, so you don't need to rush. Okay, I'll move this up. I can, Cindy, I'll give you a copy. Yeah. Okay, so when we multiply, we add the exponents because this is a base x, this is a base x. That means I can put them together. It's the same thing. So -3 times 2, -6. And I get x to the 7. Okay, but what about right here? Are my base the same? Nope. So that means I cannot combine these with the exponents, but I can still write it like this. So -3 times -2 is +6. That's why the sign changed right here to just +6. And then x squared y, I just leave it as x squared y. X squared y means x squared times y, which is the same thing right here. Just looks nicer. No brackets, nice and neat. Okay. Okay, so in terms of algebra, that's everything we need to know. Okay. We did also mention zero and negative exponents. Okay, so don't forget about those. Anything raised to the power of 0 is?
0,
1. Okay. What do you do with negative exponents? Flip the base. Okay. Don't forget that. We did this. So example here. 5 to the power of 0 equals 1. -5 to the power of 0. -1, because the negative is on the outside. So there's no bracket. So it's just 5 to the 0 with a negative to it. So -1. Okay. What about 20 to the power of -1? 1 over 20, not -1 over 20. Remember, the negative exponent has nothing to do with your number being positive or negative. Last one. 3 over 4 to the power of -1 is 4 over 3. And again, it's not negative. This negative only tells you to flip it. Doesn't make it positive or negative. Okay, last thing we talked about, scientific notations. Scientific notations. So 0.00345. When you write that as a scientific notation, it is. Oh, sorry. Let me move this in. Pedro? I like your answer.
3.45.
Yeah.
Times 10 to the negative 3.
Perfect. Okay, and negative 3 because it's a very small number. You're moving the decimal to the left 3 places, so it's negative 3. Okay, and similarly, if I have 3, 4, 5, 0, 0, 0, 0. Okay. Addition?
3.45 times 10 to the power 6.
And the power of 1, 2, 3, 4, 5, 6. You're right. Yep. 6. You were right. Okay, and so remember with the negative exponent, you get that really small number. Positive exponent, you get that really big number. Okay, because you're moving the decimal place to the right. Okay. That's chapter 3. All of chapter 3. That's all of chapter 3. Okay. Yeah.
You have to remember the definitions, right? For the degree, constants.
I don't think, not really definitions. So I might ask you, what would you do? Like, for example, like this. Add, subtract, multiply, but I won't call those definitions. It's more like methods. Okay. So you are responsible to know all these for the test on Tuesday. I have, let me see, the review. So let's start doing the review, working on the review in class today now. Okay, so let's quickly pick up number 1. Since we're doing the review, I forgot to mention about the degrees degrees. So let's go over it together. Just number 1. Find the degree of each polynomial. What is the degree here?
1.
Degree 1, because it's the exponent on the variable. So in this case, 2x is the same as 2x1, so it has a degree 1. For the sake of the review, how many terms does this have? 1 term, and so it's called a monomial. What's my coefficient here? Good. Coefficient 2. Okay. You didn't have the question didn't ask for all this, but I thought for the review. All right. What is the degree here? 4. Right. Degree 4 because that's the exponent on the variable. How many terms do I have? 2 terms. So it's called a binomial. Good. Okay. What is my coefficient? Michaela? 5. What is my constant? 9. Good. Whoops. Okay. C. 1C. What's my degree here? 2. Again, highest degree among your terms. So this has a degree 2. This has a degree 1. So it's degree 2, the higher. 2 terms. So it's binomial again. Okay. What is my coefficient in the first term? What is the coefficient in the first term? And the second term? My coefficient in the second term is negative 9. That's right. Yes. Okay. What about constant? Yeah, there is none. There's no constant. Yeah, I was checking you guys to see if you guys really understood. All right. Degree of this polynomial. 5, that's right. Okay. Degree here is 5 when you add it. Degree here is 2 when you add it. So therefore, this one has a degree of 5. 2 terms again, so it's a binomial. What's the coefficient? What's the coefficient in either term? 1. That's good. And again, no constant. Okay. Degree? What's the degree here? Pedro? 3. Yeah. What do you call this type? Polynomial, because there's 4 terms, so we call it a polynomial. Okay. Coefficient 1, coefficient 1, coefficient -1, and coefficient 1. Okay. Yeah, so I know for number 1, I didn't ask all of this, but I just wanted to go over it as a review. Okay. So I think you guys started on 2A. 2A. How many of you guys wrote this for me? Anyone write this? All right. What did I do wrong? They're the same thing, right? They're like terms. So this is not in descending order. The coefficient doesn't count. So this is just simply, I can group all these together. They're like terms. X squared, x squared, x squared. So my answer here is just simply
8x squared.
Yeah. So, all right. This is not descending order. Descending order is talking about exponents. Okay, not the number. Okay. So I know some people probably got tricked. So be careful with that. Okay, and then these, write down the group-like terms first, and then write in descending order of exponents. Okay, I'll give you guys some time to continue, and then we'll take up more of these. Number 2. Okay, what can I group this x with? Yeah, so x plus x is? Okay, what about the -7?
-1.
And?
-2.
And that would give me?
No, what? Negative.
-10, right. So when I came around, I saw some people write it like this. Remember, you need to connect between the terms. You need a connector. So if it's -10, then it's minus. If it's +10, then it's a plus in between. And then the plus x to the 4. So if I write this as my final answer, will I get full marks?
No.
Why not? The order, right? Descending order of exponents. So I need to rewrite this as x to the 4 plus 2x minus 10. All right. Descending order talks about the exponents. The degree of the exponents. Let me rephrase that. All right. Addition. What goes with x?
I cannot see. So,
And then good. Okay, so Annie, what's wrong here? Yeah. So connect it with the sign. Okay, next one. Okay, what happened to the XS? They cancel out each other. XS minus XS, they're gone. And then I have negative XYZ squared minus 4 cubed. Alright. Is this the right order?
No. I think.
Who says yes, this is the right order?
What is the right order?
It has to write it. We have to write in descending order of.
Would it be
Wait, yeah. Minus XYZ, yeah.
4Q.
All right. Is this the right order?
No.
Yes. This is
Wait, is everything
yeah. This is you can simplify this to what is it?
64.
64. Yeah. So it's just a constant. So constant do go in the end. So just because you see a cube here, remember the descending order applies to the degree. A constant does not have a degree. Okay. Number 3, last one that we'll take up for today, and then I'll let you guys finish the rest for homework. So Jackson T's car rents hot rods to buyers. He bought 10 Dodge and 15 Chevrolets. Okay, so here's the thing. Create a single polynomial below. That models the total value of the car Jack's owned after a number of years. You may use the variable y to represent years. Let's see. Who wants to tell me the equation? Who likes cars? Brian, you want to tell me your equation for 3a?
10 brackets 35,000 minus 520y brackets plus 15 bracket 42,000 minus 649 bracket.
Perfect. Okay. Let me just check to see. Did I write? Okay. So this right here is an expression. How do I make it an equation? No, that's still an expression. So what's the difference between an expression and an equation?
equation has an equal.
Equation has an equal. So for this one, let's say we want a total value, then we can write t equals that. All right. So this part A just asks you to write a single polynomial, which we did right here. And then B is when we'll simplify it. Okay. So to simplify it, that means we have to multiply this with this, multiply this with this. Very similar to the example you guys did yesterday in class. So when you multiply it out, you get 350,000. Take away 5,200y. Plus, what is that? 15 times 42,000. 630,000 minus 664 times 15. 9,960y. Okay. So don't forget, the numbers can go together. The variable term can go together because they're like terms. So your final answer right here is 350,000 plus 630,000. So 980,000. Take away 5200, 9960. 15160y. Okay, so this is my simplified equation. After 14 years, I'm going to replace this y with a 14. So 980,000 take away 15160 times 14. So what is the value of all the cars? 15160 times 14. Pedro, what did you get?
$767,760.
Perfect. I got the same thing. Don't forget the dollar sign because we're talking about money. And yeah, all this So imagine all this, simplified it down to just this right here. And then instead of plugging the 14 in like everywhere, you just have to plug it in one time after you simplify it. Okay. So again, this is a very similar example from the one that you guys did yesterday in class. If you have questions about this, you can feel free to ask me. Okay, so please do finish the rest of the package for homework. There's not really that many. I just gave you guys a lot of space. That's all. There's not a lot of questions. And then we'll take up the rest of it tomorrow.